Hi, my name is Mr. Cho and I welcome you to my study room. If today is your first time, then I want to encourage you to subscribe to my channel for more videos. We go on straight to the study for today. For my last few videos, I've been talking about the nature of roots of a quadratic equation. And I just want to dedicate today's study to solving past WASSCE questions that require you to use the idea of the nature of roots of a quadratic equation in solving. Let's take the questions. Thank you. Question 1 says, if 4x squared plus 5kx plus 10 is a perfect square, find the value of k. What we need to understand is what a perfect square means to what we are doing. A perfect square is the result we get when we square a number or when a number multiplies itself. So if they tell us that this question here or this quadratic expression here is a perfect square, then it means that it has a repeated root. And from the earlier video, I'm sure we can remember that for repeated roots, the discriminant will be equal to 0. That is just what I'm going to write now. And from the expression there, we can see that A is 4, B is 5k, and C is 10. So now, that means that 5k all squared. We need to put the 5k in parentheses, because if you don't do that, it means that it's only the k that is being squared. But the b is not k, the b is 5k. So we need to square both of them by putting the 5k in parentheses. Minus 4, our a is 4, and our c is 10. Should be equal to 0 if the expression is a perfect square. Let's simplify further. I mean 25k squared minus 4 for 16 times 10, 160. 160 equals 0. And this means that 25k squared will be equal to 160. We divide both sides by 25. We're going to have k squared equal to 160 over 25. K will be equal to plus or minus the square root of 160 over 25. This will give us plus or minus 4 over 5 root 10. Therefore, k equals plus or minus 4 over 5 root 10. And that is our answer. If we fix this into our expression, it means our expression now becomes 4x squared plus 5. Our k is plus or minus 4 over 5 root 10. x plus 10, and this will give us 4x squared plus or minus 4 root 10 x plus 10. Let's just verify with our calculator and see. So our A is 4. Our B is, let's use a positive first, 4 root 10. Now C is 10. Let's see the answer. Yeah. So our answer is negative root 10 over 2, or negative 1 over 2 root 10. The fact that the x is only one answer is a sign that this has repeated root. Remember the way I explain it? I explain it under repeated roots. Then let's take the negative 1, 2. The same thing, so we are only changing the b. The b is negative 4 root 10. The c is still 10, yeah. So again, the fact that the x is only 1, is not x1, x2, means that it has repeated roots. Then we can conclude that this answer is correct. This is the answer for K. Thank you. Let's go on to the next question. The second question is, find the values of P for which the equation 2P plus 3 all x squared minus 6x plus 4 minus P equals 0 is a perfect square. This question 2 is just like the very first question we solved, but only that this is a bit more complicated, or let's say it has a binomial as the A. But we are just going to use the same approach throughout. So as explained earlier, if the equation here is a perfect square, then it means that it has repeated roots. And for a repeated root, the discriminant is equal to 0. So you go and write that. And we know that our A is 2b plus 3. B is negative 6. And C is 4 minus P all together, because the C is all the terms that don't have x attached to them. Our A is the coefficient of x squared. Our B is the coefficient of x. And our C is all the terms that don't have x attached to them. In other words, the constant term. And now we are fixing this into the discriminant. So we are going to say that negative 6 all squared. Remember, again, the negative 6 must be in parentheses because the 6 is moving with the negative. If you don't put it in the parentheses, means that it will only square the 6, which will give us negative 36 instead of positive 36. Minus 4. Our A is 2b plus 3. then our C is 4 minus P. Anytime the terms are moving together, you have to put them in parentheses, and this is equal to 0 if the equation is a perfect square. Let's now expand and move together. Negative 6 squared is 36 minus 4. Let's expand the parentheses, then we come and expand the bigger one outside. So this times this is 8p. This times this is negative 2p squared. And this time this is 12. This time this is negative 3p equals 0. This will give us 36 minus 4. Then we group like, then we get negative 2p squared plus 5p plus 12 equals 0. We will now use the negative 4 to expand what is in the parentheses, and that's going to give us 36 plus 8p squared minus 20p minus 48 equals 0. Rearranging terms, you are going to have 8p squared minus 20p minus 12 equals 0. We can divide through by 4 to reduce the coefficient. So 4 dividing here will give us 2p squared minus 5p minus 3 equals 0. This also gives us a quadratic equation. So we go ahead and solve the quadratic equation. It's in P, so we have P here, P here. Now our A for this new quadratic equation is 2. Our C is negative 3. Then A times C will give us negative 6. We want two factors of negative 6 that when we add, we are going to get negative 5. And that will be negative 6 and positive 1. So here, minus 6 plus 1. But that is not all, because the A is 2, is not 1. We have to divide the second terms of each factor by the 2. So here over 2, here over 2, which is the coefficient of p squared. And that will give us p minus 3, p plus 1 over 2 equals 0. Then, as you knew about the null factor theorem, you're going to see that if the product of these two is 0, it's either p minus 3 equals 0 or p plus 1/2 equals 0. And now p will be equal to 3 or negative 1 over 2. It means that if this equation is a perfect square, then our p is 3 or negative 1 over 2. Those are the values of P. So maybe let's just conclude that therefore the values of P are 3 or negative 1 over 2. P and negative 1 over 2. And again, if you want to verify whether indeed when we fix it there to be a perfect square, you can just go and pick each of the P and go and fix it into the equation and check with your calculator to see. Let's take another question. The next question is, if the quadratic equation px multiplying x minus 1 plus p plus 3 equals 0 has real roots, find the range of possible values of p. We need to expand this first for us to have our quadratic equation clearly. Let's do that. Multiplying this will give us px squared minus px plus p plus 3 equals 0. In this case, our A is P, B is negative P, and C is P plus 3. And do you remember what we said when we were explaining real roots? Yes, different roots are real and repeated roots are real. So just because they say it has real roots, we cannot conclude that that is greater than. It means that it can be both situations. So we will just state that for real roots, the discriminants will either be greater than or equal to 0. Yes. Because when the discriminant is greater than 0, we have real root, and when it's equal to 0, we have real root too, because different root and repeated root are both real root. So when the question just says that the equation has real root, you have to use greater or equal to, because both of them will give us real root. That means we are going to have negative p all squared. Remember to put it in parentheses, minus 4. Our A is P and our C is P plus 3. Now be greater or equal to 0. This will give us P squared minus 4. This will give us P squared plus 3P greater or equal to 0. When you go ahead and expand the second term to get P squared minus 4P squared minus 12P greater or equal to 0. Simplifying further, we'll have negative 3P squared minus 12P greater or equal to 0. when we divide through by -3, we are going to have p squared plus 4p. Remember, we are dividing through by negative, so the sign will change to less or equal to 0. Then we factor p out to get p plus 4 less or equal to 0. So we are going to apply how we solve quadratic inequalities, which I treated earlier, so it's in one of my videos. When we turn this to equation, we are going to have p plus 4 equal to 0. That means our p is either 0 or -4. And like I said earlier, we are applying the idea of quadratic inequality. So if I'm using the graphical method, let me just do it here. I'm going to have my graph. I have my 0. Let me sketch this again because of our numbers. I'm going to have my graph. I have my 0. And I have -4 to the left of 0. Then looking at this inequality, our A is 1, which is positive. So our graph is going to be U in shape. This has also been explained earlier at the introduction into quadratic equation, which I have a video on why it is U shape. Then after getting this, the whole expression here is less or equal to 0. That means you are shading, because of the less or equal to, you are shading the part of the graph that is below the x-axis. Remember, this is x-axis and this is y-axis. So we are shading here. That means our range of value is between -4 and 0. So our p will be between -4 and 0. And because the operation is solid, having the equal to under, you are going to have -4 less or equal to p less or equal to 0. So the range of values of p are between -4 and 0 inclusive. That means they are -4, -3, -2, -1, and 0. Maybe we can take one more question. But before we go on to the next question, I just want to come back to explain something here. When we got here, I divided through by -3, which changed the direction of the sign, the greater than or equal to less than or equal to, which is a basic knowledge in inequalities. But then let me just explain further that in case you forget to divide through by -3, if you solve this one from here, you are going to get the same thing, but only that, let's take it as, for here you have to reduce it because it will help you to solve. So let's take it as you just divided through by 3 and not -3. we are still going to have negative p squared minus 4p greater or equal to 0. And these are the differences. If it remains greater or equal to, first of all, remember that when you factor your p out, it depends on what you want to factor out though. You can factor p out still, or you can factor negative p out. When you factor p out, you are going to have negative p minus 4. And when you factor negative p out, you are going to have, which will still give you p equals 0 and p equals negative 4, just like we got here. But then another difference will be when it comes to the graph. When you sketch it, first of all, because after dividing through by 3, your p is negative p squared minus 4p. It means that your a is negative, so your graph will look like n or n shape. And then also, because of the greater than or equal to that remain, you are going to shade the top of the curve, which after doing, you are going to get the same answer we got here. Anyone confused about this can just go back to my video on quadratic inequalities. These things I'm talking about have been explained very well in that one. I think we can move on to the next question now. The next question is, a function f is defined by f of x equals 4x squared plus kx plus 9. Find the value or values of k if the x-axis is a tangent to the curve. In our solution, we need to find out what the whole question even means. It said that find the values of k if the x-axis is a tangent to the curve. If the x-axis is a tangent to the curve, it means that it has repeated roots. And again, I would just encourage you to revisit my short video on the explanation of repeated root, and you will see the diagram there that if a quadratic equation has repeated root, the curve will only touch the x-axis. It will not cut it. And you remember in other videos that the tangent to a curve is a line which just touches the curve and not cut through. So because of that explanation, that with repeated root, the curve only touches the x-axis and then goes back, that is what will give us the understanding to this question. So we are going to use repeated root for that. And first of all, we have to list our a, b, and c. Our a is 4, our b is k, and our c is 9. And we know that for repeated roots, our discriminants will be equal to 0. That means k squared minus 4, our a is 4, our c is 9 equals 0. And that means k squared minus 144 equals 0. K squared will be equal to 144. K will be equal to plus or minus square root of 144. K will be equal to plus or minus 12. Therefore, the values of k are 12 or negative 12. I'll give you the last one to try on your own. Feel free to share your answer with me in the comment box. And that question which you have to try on your own is the roots of the quadratic equation x squared minus 2 multiplying 3k plus 1 or x plus 7 multiplying 2k plus 3 equals 0, where k is a constant, are equal. Find the values of k. Like I said earlier, solve this and feel free to share your answers with me in the comment box. But just to remind you quickly that this looks a bit complex, but not as complex as you might be thinking. B, the whole of here negative 2, and then multiplying the 3k plus 1 are all the coefficient of x, and the whole of what is here is also the constant term, or the c. Just take your time and expand each of them in the formula, work it step by step, and come up with your answer. Thank you. Yeah, welcome back, and I hope these few solutions have helped your understanding of the nature of root of a quadratic equation in a better way. I want to advise you to go ahead and solve your own questions on this so that your understanding will be better. It's just up to you to read the question. When you read the question, you find out what exactly the question is requiring you to find, and the relationship between the curve and the x-axis or something, or the roots. And then when you are able to determine the nature of the roots that the question is talking about, then you find out what does that mean for the discriminant. Then after that, you try to locate your a, b, and c from the quadratic equation, and then there you are, you solve. Remember that if it is distinct root, real root, or complex root, it's very likely your final answer will involve the use of quadratic inequalities, which I've already dealt with in one of my videos, solving quadratic inequalities. I used about 3 different approaches in solving it. So the only way you will just solve it as a quadratic equation is when it has repeated roots or equal roots. But if it has real roots, if it has complex roots, or it has distinct roots, and the calculation ends up in a quadratic inequality, then it's obvious that you have to use the solution to quadratic inequality to solve. How to get the solution for quadratic inequality is different from just a quadratic equation. With a quadratic equation, you are going to get 2 solutions maximum. But then with a quadratic inequality, you are going to get a range of values. It's going to be a range of values, not just 2. So it is very important to take your time and solve it well. Yeah, so on this note, I just want to encourage you to subscribe to my channel for more of these videos if you haven't done that yet, so that anytime I upload a new video, you will just be updated. Thank you for making time with me, and I hope to see you again. Continue to study hard, because it is only when you study regularly that you have better understanding of mathematical concepts and being able to apply it. Thank you for making time with me, and I hope to see you again. Bye-bye.